Hi, fellow geochemists and geochemistry enthusiasts. Welcome to Geochemist Tea, the only podcast for people who love geochemistry with a side of tea. Our mission is to inspire future geochemists and to introduce our listeners to niche geochemistry topics. I'm your host, Sam Scher, and this month we're talking with Putra Sadikin about the ins and outs of historic geochemical datasets. Putra is the IOGAS software product manager at Imdex. So to us geochemists, he is the person that mentors the Imdex team and us on digital geoscience applications, including geochemistry and analytics training. He's also in charge of the roadmap, so he's an important guy to know. So Putra, welcome back to Geochemistry.
Thanks, Sam. It's good to be back.
So Putra, as a friend of the show, because if anybody hasn't heard it, listened to it before, he's been on once before. Anybody that wants to know more about how Putra came to be part of the Imdex team and heading up IOGlass, please head to our episode on lithogeochemistry. I think that said, what would be interesting though for our listeners is how have these last 2 years been for you and your career? Is every day an evolution or what's been going on?
Yes, last 2 years. So if we're looking at early 2023, the sort of things that we see in the industry and in the market has been quite interesting. We see a proliferation of something like ChatGPT and LLMs and using AI in every single thing, which is good. I think it's good for the industry to be ahead of some of these technologies. And I'm really proud of some of the work that we're doing currently here in Index on that front. And within the last 2 years, some of our biggest challenge is trying to talk to our customers and trying to get a lot more people to understand that some of these technologies are here already, and we should really take advantage of them. So without going into too much detail, I think the last 2 years have been interesting, just on the roadmap front, and trying to balance it out with preaching to the masses about geochemistry and data science, especially with more and more people start to do this sort of thing and then programming language, and we can already do some of these stuff. And I guess, and I'm just putting my a bit of a bias hat here, but we can already do some of these stuff like easily from ages ago. So why don't we use it instead? But yes, I know it's a bit of a biased perspective, but I think with that being said, I think there's a world where if you already use sort of Python or programming languages and you use IOGAS, you can put one and two together. But anyway, more enough about that. I'm not here to exactly talk about that, but yeah.
That's pretty fair. I do a bulk of my work in IOGAS, but that said, I also do a little bit of stuff in programming languages, and there's a role for both of them, and it just depends on what you want. I lean on the lighter side of doing things in terms of programming. But that said, I think there's a role for both of them. And working as a geochemist in industry, I'm thrilled that we have gas available to us. So,
Oh, absolutely. And I think these are tools, right? And tools for what purpose and how do you put them together? In my head as well, from my point of view, there's not a world where I see both and all of these programming languages cannot coexist together. And I guess always serve as a way for people to bring their data in and visualize them in other places. That halfway house between getting your data in, making sense of the data with your geochemical or any interpretation that you do, because I guess it's not just for geochem data, but what can you do with it in order to put it into context of whatever it is you're doing from exploration to production. But
yeah,
yeah.
anyway, it's a good plug, especially for our younger listeners that maybe aren't as familiar, or to that end, some of our older listeners that aren't that familiar with gas. Do you have any new tips or advice to give our listeners wanting to break into geochem or using programs, programming languages? What do you got?
There's never a better time to actually get into geochemistry. The amount of free data that you can get from the internet in terms of public domain data is really incredible these days. When I first started in the industry, yes, we had industry data, public domain data. But these days, it's just incredible the sort of stuff that you can get online, especially with the geological surveys here in Australia. Each of the state in Australia has a geological survey, and each of them has massive repositories of geochemistry data. So, particularly like to shout out a geological survey of Western Australia and a geological survey of Queensland. Those guys have really good data sets online that people can download and see. And the reason why I'm putting that as a plug is because if you're want to learn about geochemistry, the best way to learn is having some real data to play with and having something to play with the data. And of course, biogas. That'll be my last plug for the night. Sorry.
Lies.
But if you're a student, if some of your students are listening to this, biogas is actually one of the softwares that we get a pretty good rate for students. If you're ever interested, just reach out. But with that being said, there are so many more options these days to start playing with geochem data, right? You're not just limited to say biogas even. With that being said, if you compare this to 20 years ago when all you had was Excel and probably some programming language, you were in a world of pain. So I think there's never a better time to get into this. And in terms of resources as well, guys like Scott Haley with his tutorials up online, I think that's just a valuable resource. We didn't have that when I was growing up, really. When I was just starting to get into the industry, we didn't have that kind of resource. So that's another thing to really call out for. And of course, podcasts like yourself and even GeoHug, Jess's GeoHug is quite amazing in that sense as well. You can learn a lot of geochem. There's actually so much geochem in her podcast, which is quite amazing. But anyway,
I've taken Jess's stuff, and this is a shout out to anybody that wants it. I've put a geochemistry playlist of it on the geochemistry YouTube page. So
that
if
is
anybody
awesome.
wants to just wants to quickly find all the geohugs that have to do with geochemistry or geochemistry adjacent, I already got you guys covered. And Jess
Nice.
knows.
Nice.
Yeah. Cool. No, it's really good advice. And I also agree the way that we're able to access data sets, access information. And if there's things that you guys want to hear, just ask. And I know here I'll try and provide somebody that can talk to you about it. The Australians have done an incredibly job. The Canadians do a pretty decent job. I have recently been looking through the US data sets, and I would just like to say it out here loud and clear. If anybody from the USGS or Department of the Interior is listening, do a better job. Look at those other sites because it is really hard to get access to data. It's horrific. So anyway, we don't have to talk about this anymore, but yes, access to data, really cool, and access to information. So good points. That said, and as you very well know, Putra, no one here is free from obligatory gossip this session coming up. It's tea time. What have you brought for us?
All right. Is it okay to do a non-geology or non-geochemistry tea?
Absolutely. Yeah.
All right, here we go. So I went to a conference in Indonesia last year for the first time. No, not last year, the year before. And I have done a bunch of webinars and training to some of the people who went to this conference, right? So just public courses and things like that. So they have seen my face on Zoom and Teams and whatever. And the way that my laptop is set up on my desk is such that I look incredibly huge on screen. So when they see me in person, they were like, "Huh, you're much shorter than I imagined." I always thought you were an incredibly tall man. No.
I don't want to get in trouble with the Indonesians out there, but when I was in Indonesia, nobody was particularly tall either. And as an Indonesian yourself, what were they expecting?
No, I was exactly the same height as everyone else, but anyway.
Exactly. I also am out here as a short queen. Yes, when we finally met this year, to our listeners, me and Putra have known each other for a long time, but we've never met in person until this past year at the geochemistry conference in Adelaide. And look, we were the same height. I felt great. Most people I have to look up to. So this is nice. Yeah.
Yes, it'll be interesting to just have a probability plot of geo height
We
is
would
the
be
grand.
thrown off by people like Ian Dalrymple, who is just an absolute giant of a man, or at least I
Yeah,
perceive him that way because I'm just always
yes,
looking up.
he's an outlier, maybe.
Yeah.
Well,
Okay,
so are we, but
interesting.
there you go.
Yeah. Okay. Anyway, we could send out a survey. Survey monkey. There we go.
That's it.
How tall are you? Okay. I love it. So, for our topic here, we've been putting together, which will come out shortly after this podcast. We have been putting together a webinar on historic data sets or legacy data, whichever one you prefer to call it. And Pucha provided a bunch of articles that talk about the data and what this is and how people like to deal with it. And I've posted them all online so you guys can access them. But with this podcast here, we're going to try and dive a little bit into it. And it's not this like hidden thing in geochemistry. It's just this thing that's one of those topics that's so accepted and like every day that it's not thought too much that we need to talk about it, but which is wrong because I don't even know half the time what to do with a data set. We just spent 30 minutes before this podcast talking about a data set I'm currently working on and how nightmarish it is. It has 150 plus missing analyses on it. It's just an absolute disaster of a thing. So, anyway, I'm thrilled to be able to talk to you about this, Putra. First off, before we even get into the Q&A, can you just first define for us what legacy or historic data sets are?
So from my point of view, when we're talking about legacy data sets, is if your company buys another company, you got access to some data sets, that's a legacy data set. If you're dealing with public domain data, I think I always treat of them as a historical data set, right? So you would apply, it's basically some data set that you would apply a more stringent look at because it's not something that you're used to as a company when you're looking at your own data. So there's a bit of unknown in how it was analyzed, how and where it came from, and when it came from, sort of thing. So there's a bit more uncertainty in looking at it. And I think it's a higher level of uncertainty that you would assign to this type of data. So that's what I would call a legacy or historical data.
Perfect. And then I also, the only thing I would add is just this is why when you ask a geochemist for a quote or a scope of work, they'll often say that we're going to spend 8 weeks looking at your QAQC. Not quite
Yep.
that long, but a long time because we really want to make sure that we're comparing the same types of data. Because if not, then our interpretation is relatively meaningless. So a lot of time has to go into understanding what these data sets are. If you have metadata, that's great. Give us all the information you can, but it's just really painstaking and a long time to sort through all of this. So I'd add that to everybody out there as well that's listening. Okay, so first let's start off by talking about instrumentation and digests. So, what are some key differences in geochemical instrumentation and digests over the decades, and how have these influenced the type of analyses we can perform?
All right. So I think if we're looking at this, if we just jump back in time, we can split this into two, but with two digests and instruments, but we'll talk about them in tandem because it makes sense. So I guess in terms of digest, we went from old school Ecoregia. Ecoregia is not old school, but it has been around for a while. And simple multi-acid, so two acid digest plus AAS, and then we move on to mixed acid and fusion and ICP OES, and then all the way to selective leaches, ICP-MS, and then four acid digestion. And then over the years, when we start thinking about the effects of having a strong acid digest and how it impacts the environment with the runoffs and everything, I that's I think when we started to see more people start to use non-destructive methods, and we start to see a lot of those portable instruments becoming more used in the industry. And with some of the older methods as well, I think improvements upon improvements to some of these older methods means that you get lower detection limit and better precision. For example, these days, if you mix 4-acid and ICP-MS, you can get well below average crystal abundance and get pretty good precision for a bunch of these elements. Um, and with some of the traditional ways that we look at the data has been augmented a lot by new advances in technology. So Equiregia has improved by quite a fair bit. Things like portable PPB is also a game changer, right? If you're talking about some of the ways that you can get rapid analysis on the spot kind of thing for your gold assay. But yeah, I think over the years, over the decades, I think it has influenced the way that we look at data, and which means that if you compare data from now to the past, then you're not necessarily comparing apples and apples, and you need to be careful if someone gives you data from 40 years ago. When you're comparing it with assay data from yesterday, I think you need to watch out for that.
That's incredibly well said. And just to reiterate then, what are some of the potential challenges of using outdated or less precise digestion or analytical finish methods in order for us to interpret this kind of historic data?
Let me just pick with an example, right? If we use an example of poor element recovery as an example of less precise digestion method, if you compare acaregia versus 4-acid for some silicate minerals. So if you're looking at doing a Hallberg diagram in gas, which is like it's an igneous rock classification, you can see that with acaregia digest will show up as incredibly low values or relatively low values. Zirconium, just based on how much the acaregia versus 4-acid will digest, zirconium is probably worse than titanium in most cases. In that case, in the Hallberg diagram, things that will should be classified as rhyolite will be classified as basalt potentially. And we see cases of that all the time if you compare two methods in the same table, in the same graph, sorry. And also things like if you compare, say, 4-acid and fusion, fusion can dissolve more, but it has a higher detection limit for trace elements, as the final solution can be more diluted. And the reason why 4-acid works really well in this instance is because it's more concentrated solution, and that's why it's better for trace elements. And then you use your fusion for your major elements along with XRF. But I think to answer your question, that goes around coming back to your question. If we compare current method with a less precise digestion method, then you just really need to be careful because your background is not really your background anymore when you're comparing between those two methods. So different thresholds to look at essentially.
No, I think that your roundabout example with the Halberg diagram is exactly right too. It's just we have multi methodologies in our data set.
Yep.
And now we're geochemically saying, okay, these are basalts, these are rhyolites, these are andesites, and that's not necessarily true. And so it is something that we have to be extremely careful of. And I think it just really paints the picture very vividly. So, yeah, good example.
Mm.
So I think a lot of us are on the train with, okay, instrumentation, digest, we're on board. We understand why these make such an impact in our data sets. But I think something much less talked about is probably about analytical laboratories. Not necessarily that one is bad and one is good, but how do differences in analytical labs, past, present, doesn't matter, affect the consistency and reliability of geochemical data sets?
So I think it's not so much about the difference between the labs, right? But I think it's even if you look at the same lab, if you have methods from a long time ago versus methods that are current, I think it's important to understand the differences between them about instruments and the digest that you use. And generally speaking, your newer data sets with more current methods tend to have better reliability for certain things like rare earth elements, for example. So with older style digestion methods, you probably wouldn't get a reliable assessment of your trace elements, for example, for your rare earth elements, which is quite important. Some of these things are more relevant these days when you're looking for critical elements or I hate it when people say critical minerals, but critical elements, if you think of it like that. So, because some of these rare earth elements, they don't get analyzed to a good enough level of precision with older style methods, which means that you have a historical data set. If you're looking for some of those elements, then you might not get a good enough data for it. So reassaying if you still have access to the pulp and the rocks and things like that. But also important to understand the strength and limitation of your lab's methods. You would want to read the text sheet beforehand. You go to the website and read about it. And if you're in contact with them, then you might as well chat with them about their process. And if you have the privilege of visiting them, I would recommend talking to them directly and yeah, having a chat with them. have a chat with your friendly labs and also your CRM manufacturers as well. That's probably another important thing. If you're using CRMs as part of this process, which you will be, yeah, just have a chat with your CRM manufacturers if they can recommend ones that are good for your project. So I got a little story, right? So I was looking at some data from just this project on Danites, and the CRMs that they use weren't properly appropriate. They didn't have it, but that's because it's quite a super ultra mafic sort of Danite that they're dealing with, and there's no CRM from that company that can handle it. But anyway, I think in those cases you should just do a bit of homework and try to find a CRM that works for that purpose instead of just picking one that eh will work, but it may not work that well for the geology that you're working in. As a side note.
We love the side quests.
Yeah, yes.
I was going to say something that I found too is that certain digests say the acids will be mixed in different proportions between different labs. So what you might be doing at one lab, like an acarige at one lab should equal an acarige at another lab should equal, but it doesn't. I've also found that to be a bit interesting, weird. I don't really know how I feel about it, but don't tell me how to feel
Yeah,
other
I mean
than it
it's
gets
yeah, that's it.
frustrating.
Yeah, it's for acid from lab A, it's not the same as for acid from lab B, even though they
Yeah.
say it's the same process, same elements. But the fact that you get slightly different detection limit should be telling, right?
Yeah.
Yeah.
Anyway, it all just makes for stuff to think about when you're accountant. It's just like, hey, let's change labs. This one is cheaper.
Cheap,
Yeah.
that doesn't yeah, cheaper doesn't always mean better.
Mm.
Sometimes cheaper is better depending on what's fit for purpose for your data, really.
Yeah, sure. I just think that changing labs in the middle of a program,
Oh no, that's not good.
yeah, that's not good. Yes, in general, what do you think that geochemists should consider when integrating data from multiple labs with varying like analytical standards or anything?
Having metadata is useful, but if you don't, then you'll need to work it out, which does take up a bit of time. I think we talked about this before, but if you don't have metadata, there are only so many ways that you can try to guess your detection limit or what the methods are. And there's a bunch of ways that you can do this. If you look at the probability plot and if you notice that a bunch of samples are the same values, that's probably a telling sign that's that detection limit. But it's not always that easy to spot. So I guess that's why having a good metadata is important. And really, if you got multiple data sets with multiple detection limit, and there's many ways of dealing with that. Half detection limit is popular. We use that as a default in our data doctor and I guess, and places like Acquire does that as well, have that routine. And our data doctor also pick the lowest detection limit if we have multiple ones. But with that being said, poor digestion doesn't mean that the data is not usable. If you have poor digestion for, say, elements like titanium and zirconium, coming back to my earlier example, ratios can be used for elements like zirconium because they're consistently partially digested, if that makes sense. So things like Pierce element ratio, they will still be okay. And if you're looking at ratios of everything of your elements against zirconium, because they're consistently partially digested, so consistently partially somewhat average. So it's still okay. Consistently average is usable in a sense.
I feel like that we could apply that quote to life somehow. I'm not sure yet, but
Consistently average.
yeah. Okay, let's move on. Chat about dataset cleaning. So, what common issues will arise when trying to clean up some historical geochemistry datasets?
So that's a classic IO Global training material, right? We actually had a slide for this. So overrange values, so values that are overrange different units in the same column, combining oxides and elemental same column, which is harder to pick out, but that in different units, same column, that's easier to pick out. No spatial identifier. We're not talking about just QA/QC, but we're dealing with geology data, right? So we gotta know where they're from. So if you don't have spatial identifier, or if your spatial identifier is wrong or in the wrong place, then that's not really good. Especially when you're starting to deal with drilling data. If your historical survey data is unreliable, if you don't have access to historical survey data, how are you meant to put it in 3D? And I think that becomes really dangerous. I think coming back to my earlier point about metadata, not knowing where the samples are from, you can't really assume that they're all the same method. And it's harder to track down issues if we don't. Even things like sample contamination will be a bit harder to track down. The classic example is using a tungsten carbide bowl for your crushing. It's harder to pick out contamination if you don't have some of these information in place, if you don't have a context. And it's not just instrumentation and digest, but not differentiating between different sample mediums. I think that's quite scary if you don't indicate where those samples are from. Are they from an RC hole or are they from a diamond hole? I think the difference, while it seemed trivial, but I still think it's quite relevant, especially when you're comparing things like soil samples and drilling data. It'll be quite obvious, especially if you have spatial identifier, but yeah.
I don't really have much to add to that. That's pretty comprehensive. How do you approach data sets where the detection limits are missing or have been modified by the client without documentation? So we talked a bit about probability plots. Is there anything else that you might use?
I would ask.
Yeah. Beg.
Around do some investigation, but yeah, probability plot is my go-to. That's a starting point for guessing some of these things. I've had some success in going down the esoteric route and trying to use things like a U map or k-means clustering to pick out clusters in the data which are not related to geological process. Some of these things are quite obvious, especially with data which has vastly different detection limits. So there are some merits to using some of these tools. And I think the reason, and I should think about this a bit more, but I think the reason why those tools like a UMAP would work is because these tools are quite useful for finding structures in the data. So mathematical structures in the data that you might not have easily pick up just by looking at your probability plots, right? So I'm talking about multivariate mathematical structure. And when you're looking at a probability plot, you're looking only at a univariate space, albeit one element at a time. It is multivariate, but you're looking at one element at a time, which means that you might miss certain things. But having a mathematical approach to this would be um, one way that I would like to see more people start to have a think about.
Along the
But yeah.
lines of a UMAP, one time I was just doing a pretty standard PCA, like really basic looking at who knows what. And I was super excited. I was like, oh my God, I have found a new member in this granite complex or whatever. And I was like, this is so exciting. And it
Mhm.
turned out the only difference in it was one drill hole. And the biggest difference was chrome, and it just wasn't picked up in the QAQC. It was chrome contamination. But I thought for a
Yes.
moment I had discovered something new, and it was really exciting until it wasn't.
Yeah. Yeah, that tends to be quite common. It's
Yeah.
it especially if it's just coming from one hole. And this is one thing I would like to add in the metadata. I know we have a question on this later, but having or knowing what batch it came from is also quite useful. What batch the sample
Explain.
was on. So
Oh, batch. I thought you said bad
yeah,
shit, and I was like,
no,
okay.
no, I don't swear in this podcast. Probably shouldn't.
Whoops. Only Dave does.
Oh,
And just to close out the data set cleaning, do you have any other best practices that you have or that you use to address these errors in these types of data sets?
yeah, I think having a systematic approach will play to your benefit. And I'm not talking about doing the same thing every time, but just having a checklist of things to do to make sure you don't miss anything. Looking at univariate analysis at the start, so with a probability plot in particular, doing a bit of data validation. You can use the data doctor to do that sort of thing. Use the missings analysis tool. So that's actually one of the most useful things that we have added to look at historical data sets because it gives you, like the term eludes me, but it's you have like a checker box pattern. Basically, you can see a pattern in your data if you have data that's analyzed using one method or the other method. So that's what the missings analysis will tell you. Following on from that wavelength, I think the missings analysis tool will benefit from having a below detection limit analysis tool. But anyway, that's just something that I have in my head and thinking about after doing this podcast. Always good.
I
Anyway,
know.
yeah.
So good. I'm so excited for it. Putra and I
Yeah.
were totally brainstorming about this earlier because
Yes.
I'm
Yes.
currently mad about a data set that I'm looking at.
Not promising anything, but
No
I think
promises, but
no.
there are
Uh,
promises.
the more I talk to people in this podcast and in general, the more I get ideas on what stuff to put in, and it's quite fun. But using the search and replace tool, not many people use that a lot in I guess. So data doctor, but more specific for text and numeric columns as well. It's like a classic search and replace tool. And of course, using things like a line plot to evaluate instrument drift, if you're looking at portable instruments, but you can also use that to just evaluate the performance of CRMs if you have those in your assay table as well, and things like that. But the point that I'm saying with that is that all of those things that I talked about just in the last minute or so, all of those can be automated. Again, not a lot of people know this, but we got a macro recorder in iGas that allows you to automate a lot of these things.
Yeah. We'll work together to automate the ones that I want. How about that?
That's
Yeah.
it.
Yeah. I don't know, but it is really useful, and it's also something that I've begun to do with some of these kind of very common workflows that one does, but then also it gets tricky with these historic data sets because as common as some of these pitfalls always are, it's like they're always just a little bit different, and it's frustrating. So,
Yep.
not just you guys are frustrated by historic data sets. Everybody is. And just to talk now about just the importance of metadata, we've talked quite a bit about it. If anybody doesn't know the term, do you want to just quickly define it for us what metadata is?
People refer it as different things, but I like to refer to things that are not your assay columns as metadata. And yeah, so things like sample ID, which I think you should always have in your data set, like a unique sample ID for each sample. Spatial identifiers, because we're not dealing with just a table of numbers. We're dealing with geology, so you need to put it in geological context. So you need a few things. You need spatial identifiers. You need to know where they're from. If they're drilling data, you want to know the drill hole ID, your depth from and depth to. And then if you're dealing with soil data, you want to have things like sample depth. And if you're dealing with drilling data, you want to have XYZ coordinates, the surveyed coordinates if you can, but you also want to have information on your drill hole color and drill hole survey. I'm quite pedantic about this, but I think having a good audit trace of how you desurvey your data, what the original drill hole and survey information is quite important. And I think because spatial context is everything, you don't want to miss everything. You don't want to miss anything, especially when you're dealing with a bunch of holes that are tightly intertwined with one another. You really don't want to miss even half a meter in where you're going thing especially when you're dealing with underground drill holes as well. I think that spatial context is important. Following on from that, sampling medium, not a lot of people include this, but even if everything is from common core samples, even recording everything as the same, that's still useful info, right? Especially when you start to bring in historical and other data sets. You want to know which sample medium came from. More important if you're dealing with soil sample, but we can go talk about that for ages, right? Because with soil data, I think the list of metadata that can be included is quite astronomical, but they're very important. Critical method and lab we talk about, and CRM data, not metadata, but I just like to put it out there. If you have CRM information, just put them in your assay table. The data is critical in a nutshell. Otherwise, you're just looking at a table of numbers at the end of the day. And despite what our data scientist friend likes to think that geochem is just a table of numbers, it's really not, right? You got to remember that you're dealing with geological data. So the more information that you can link it back to geology is better.
1,000%. I can have rambled better about it. It was a very tight ramble, though. But like it is, and people are often surprised by the vehemence at which I request metadata with their geochemistry data. And it's unfortunate that not everybody has all this information, but the crux of the problem is that it's geological data. And without it, we're just many steps behind, and it just takes an age to do half to three quarters of an interpretation when you could really give them something much, much better. Good point. I want to switch now because something else that we chatted about a lot was this bend in the industry towards having field portable technologies, whether they're PXRFs, whether they're scanning XRFs, whether they're other scanning systems, and just really how that kind of added to and changed the landscape for our historical data and how we can deal with it and be able to integrate it into the programs that we're currently doing. So, to start with, I just wanted to ask a few questions on field portable tech and really just get your opinion on what some of the main advantages and limitations of using these technologies like PXRF or scanning XRF are in geochemical investigations.
So I would just like to preface this by saying that I'm a huge fan of field portable technology. I think we've come a long way in how we're starting to use some of these tools. When I first entered the industry, it was only just really be adopted when you're talking about portable XRF, but now we have portable lips, and then as you said, we have core scanning instruments. It's not like you can roll out a core scanning tool next to your drilling rig, but still, it's quite portable in a sense that you don't need to take them to the lab. If you're talking about something like portable XRF, I'm just going to pick up as an example because that's the one I'm most familiar with. With portable XRF, you obviously have the cost benefit. It's rapid. You can do it quickly. You can do it on site. You can do it at the drill rig. You can do it on the core shed. And there's limited sample prep, right? If you really want it, you can zap your core with it, but that's not the recommended way of doing it. And I go to that in a minute. But generally speaking, portable XRF compared to lab-based methods, it's good for making near real-time decisions, especially if you can automate some of those workflows in the data interp. And it can make a difference in hole planning, right? If you're not intersecting the right geology based on your geology and geochemistry, do you just terminate the hole, or do you go elsewhere, or do you prioritize which samples to send to the lab? And also the best part about it is that it's non-destructive. So you can use it as a pre-selection method for sending samples to the lab. With a good system, and by good QA/QC and things like that, you can run through hundreds of samples in a day. And so here are the limitations. Even though I'm a huge fan of portable instruments, there are limitations. The biggest is you are your own lab, so you need to think like a lab. And every time I say that, I just let that sink for a minute because that comes with implications. If you're your own laboratory, you need to think like a laboratory. So things to look out for is that you need to deal with sample homogeneity. So you can't really just zap your XRF on a core. You can, unless you know what you're doing. But if you're doing geochem characterization, you want to do it on homogenized samples to deal with the matrix effect. You need to, regardless of what you do, what sample medium, what you're zapping it on, you need QA/QC, right? So you need to have a procedure to implement standards, blanks, and duplicates into the process. And you need to just do a bit of just an orientation study to come with it. So you need to create an orientation study to determine what's the optimal reading time for the precision that you're after, whether that be 30 seconds, 60 seconds, or whatever. And and there's also a tricky part at the end where you want to calibrate or correct the data against lab data. And this becomes a bit muddy because there's ways. I'm not talking about the instrument calibration, which I'm not going to talk about, but I'm talking about the data correction, data calibration against lab data to verify the chemistry, and you can use the correction factors. But there's a bit of gotchas in there. So you just need to be careful once you get up to that stage. But generally speaking, fantastic. We have this in our hands. We have portable XRF, we have portable lips. Lips is a bit different to what I'm talking about, but generally speaking, you need to think like a lab, which I think people are aware, but I think yes, it just needs to be emphasized a bit more, right? Because that means you need to apply more stringency to the data to reduce uncertainty in your data interp. Sorry for the ramble.
No, it was so good. And it's so necessary. It's, in my experience, it's really hard to implement these on site, not because the setup part, which just takes some time, some guess and check. Is it 60 seconds? Is it 30 seconds? Is it 15 per element? But really, what makes it hard to implement is the fact that the companies, the onus is on them to become their own lab
Yep.
and to also have to homogenize the core to, if you want to do lithogeochem, if you want to do ultra, you have to put in so many extra steps that people don't necessarily think of when they first think of doing this, that it becomes actually a huge amount of work. And then you have people thinking at the end of kind of the implementation phase, okay, is this something that we really want to continue with? Which is totally fair because maybe then this isn't actually something that's for them and maybe then the lab is better. It just really depends on a whole number of things. Maybe it comes down to cost in the end, who knows? But no, such good points. We've touched on it briefly with data treatment, but people will collect data from a lab and maybe they switch to something like a PXRF or an XRF scanning system. Is there any way that these two data sets can be combined? Or what do people tend to do with them? Do they just treat them separately?
I think it's important to treat them separately, especially when you have lab data and you want to compare it against portable instruments. Like for once, you're dealing with a different suite of elements to deal with, and portable XRF, for example, doesn't do light elements that well. And if we're talking about switching to a portable XRF instruments or a core scanning XRF sort of workflow, we need to think about what's the advantage and the considerations when you're comparing between those two methods. Of course, we have the speed and the price factor when you're talking about on-site analysis, so more rapid interpretation of your data. But if you really want to implement portable instrumentations to your workflow, and this applies to everything from what we talked about, but having an on-site sample prep plus portable instruments will give you the sweet spot in quality, time, and price when compared with lab data. So there's the quick and dirty way, just zap your portable instruments on your core, but that's miles away from lab-based data. But I think there's a sweet spot in between where you combine good sample prep, good QA/QC, standardized way of looking at things, and routinize a lot of these things, and use that as a halfway point between portable instrumentation and lab analysis. You will not get close to lab data, which means that you can't compare them as apples and apples. They're still apples and slightly smaller apples, if that makes sense. But they're not exactly apples and oranges either. But I think you gotta know your fit for purpose elements for PXRF. So I mentioned light elements, but major elements like iron, calcium, sulfur, and some economic commodity elements like copper, lead, zinc, nickel, arsenic, those guys are quite okay with portable XRF. So they are fit for purpose. So knowing what fit for purpose is with your data. And I think that's why it's important to put CRM, uh, a good CRM into this. And I think one thing you want to be careful about is when you compare your data against expected value from a CRM for your portable XRF is that you want to compare the expected value for a comparable method. You cannot use portable XRF on the CRM against the result from the CRM. You want to compare it with something somewhat similar like portable XRF and a whole rock digest with it. Lab XRF for the same CRM samples. Otherwise, they're not the same thing. So
That's
that's
a
just
really
a
good
side
point.
note into
Yeah,
CRMs.
yeah,
Yeah.
yeah. Mm. We had a Steve Tabanis on the show maybe 3 or 4 episodes ago, and he's got a company now that's creating PXRF and Libs CRMs. So there's a little plug for you, Steve. But the point is that people now are starting to see the value in doing CRMs for field instrumentation as well.
Yep.
So that's a really cool step change that I think that we have. Something else that I was thinking about. Do you think some people have really moved towards this is our primary analytical tool? What are the pitfalls for people that have decided on this? Do you think that it's truly possible to move away from lab analysis or what?
Yeah, so I was having a good chat about this with someone the other day, and this is just going off on a tangent, but when we're talking about the move to use a more portable instrument to get your assay data and what it means for the future of assay data as a whole, right? Are we moving away from having real assay values and are we just estimating chemistry from a proxy? And I think what I'm when I really want to get to is that portable instrument data is not meant to be comparable to lab data because of sample prep and simply because of physics. Just the physics are different when you think about those data. So you need to know your fit for purpose elements, like I mentioned earlier. Elements obviously are bad. in terms of fit for purpose element, but higher energy portable XRF device, one of those tabletop high energy portable XRF can perform a bit better, but you're still bound by the rules and the laws of physics. But having a good sample prep system and built-in best practice QA/QC, that that goes a long way in making sure that it's a routinized lab-like way of looking at the data. So you can think of it, so when you're using portable technology as a primary analytical tool, whether it be limitations, right? When you're exploring remotely and you need to make decisions on the fly, on the go, and you can't really afford to send your cores or your samples to the lab when you might not even get the result back in 6 months. So I'm talking about exploring in really remote locations. So say if you're exploring in somewhere like Greenland, for example, or some incredibly remote location where it's not easy to send your samples off to the lab, even by helicopter and things like that. And I think that's where having a more up to date, not up to date, a more speedy way of looking at the data, that's when it becomes quite powerful. And again, sorry for the ramble, but yeah.
That's what we're here for.
Yeah. But yeah, basically, if you have a good sample prep system and just built in best practice QA/QC way of looking at your portable instruments data, I think it can go a long way of making sure that it's somewhat comparable to lab data. But at the end of the day, they're not the same. And knowing the limitations when you compare, because eventually at the end of the day, if you do want to send some of the same samples to the lab, it's important to make a distinguishing flag, right? So it's important to distinguish them when you interpret them at the end of the day.
Such a good point. Look, I think I want to pivot from here. And I think it's been super interesting to talk about field portable technologies as another really type of, maybe they're more modern, but they're still in a database. They'll still be a historic part of your data set, right? It's still going to be legacy data because it's something different that you're going to have in there and that you're going to have to deal with when looking at other data sets that you have or other data analyses that you have in your data, in your database. Presumably, hopefully, it's not in Excel because that's not a real database.
Mm-hmm.
Had to throw that
Oh,
in.
one one other
Go
thing,
ahead.
and sorry to interrupt, but with
No worries.
if you're looking at portable XRF data in a historical data set, one thing that would be good to have is the original data columns and the original error columns, because surprise, they get missing if you're dealing with
Mm.
historical and they just say, oh, it's from portable XRF. Well, where's the original error columns then if they're
Mm-hmm.
portable XRF? And and if they have already replaced their below detection, or what do you call it, less than
Two
LOD. Yeah,
2D
yeah,
or whatever they're calling
yeah,
it.
yeah,
Yeah.
yeah, yeah. If you're calling it less than LOD in your XRF
Mm.
data, and if they already replaced it with something, you should ask them what they did, because there are many different ways of assigning that detection limit value. There's a spec sheet that comes with the instrument, but there's also another way of determining below detection limit values, as we all know, for portable instruments. So
Mm.
I think having the original data is still quite important, and I would argue that's the most important metadata that you can get from a historical portable XRF data, along with other information like reading time, what instrument, temperature, that sort of stuff.
Yeah. Oh my God, that's a really good point. Yeah, because to say something else on it, when you get an export from an XRF, what it's telling you is not just that this is 10 ppm, give me an element, 10 ppm niobium. Let's go for it. So let's say that it's giving you that, but let's say that the 2SD number that they give you, which would be in the column next to it, adjacent to it, would be like 8 or something. Two standard deviations means that you don't have your 10 ppm niobium. It's actually below the detection limit of the instrument, and you only know that from looking at the column adjacent to it. It's not that hard once you like grasp the concept of it, but it becomes this whole thing that it's just, why can't you just tell me from the beginning that it's below detection? But anyway, it's a
Yep.
very helpful piece of information to have. So yeah, don't get rid of those initial exports that you have and change them to like to confine to or conform rather to any kind of database that you're using. It's really helpful information to have when somebody's taking a look at it later.
Yeah, and
So,
you can also plot your original element against the error column. And if you plot them
yes.
up in a scatter plot, you can see what's going on a bit better as well,
Mm-hmm.
rather than
Yeah.
just looking at the table of those
Good point.
numbers. Yep.
Yeah. Could be binary, but you could actually be a scientist about it and plot in a scatter plot. Look, we've talked about the pitfalls and how frustrating historic data sets can be, but let's give them like a chance to shine here. Could you just give us an example of a time where you got burdened perhaps with an historic data set, but in the end, it ended up really helping you? The fact that you had five different companies' data, and maybe not all five of them was helpful, but maybe four of them. And without the fourth one, you wouldn't have had the interpretation that you were able to have.
So I got a couple of stories, and I think one of it we
Love that.
touch on. One of it we touched on in our webinar on that leapfrog geo, I think a while back. So this is with the Flin Flon dataset, and where we see multiple detection limit, and I think the difference between instrumentation in this instance, you can see clusters in the data, but if you don't have the information beforehand, you would wrongly assume that one cluster is elevated in certain elements compared to the other, whereas the difference is due to the difference in the background value because of the difference in the detection limits. But one thing I would like to highlight is that some public domain data sets that I see, a lot of them don't actually have metadata built in, and I think it's because they want to. A lot of these samples have been reanalyzed with the latest and greatest analytical method, so that's fine. But if you're talking about just dumping historical data sets into a public domain data, the least you can do is mention what methods they came from. Otherwise, it's just a bit of guesswork at the end of the day. But the thing about dealing with historical data sets is that the more complex your data is, more unknown, I'm trying to articulate this, but the more unknown your data is, the less visibility you have as to where it came from, the more likely you would be in creating false interpretation out of it or erroneous interpretation that doesn't have to do with the geology. So I think that's like my key takeaway from that spiel.
Yeah.
Yeah, but yeah, that'll be how I would summarize it.
Do you think that there is merit in saying that, okay, I have data from three different companies in this data set, and one is brand new data. It's really high quality data. I can do incredible things with it. With the other data sets, they're not as incredible, but they're also not horrific. Do you think there's something that you could do, say, with some kind of leveling scheme or maybe some kind of ratios like afterwards? Would there, I guess what I'm trying to ask, is there a world in which like we're or just many of our analyses are just not ignoring all the older data that we just would be like, oh, I don't want to deal with this, but we can actually use it.
Yeah, I think there's a world where you can. So there's two things to this, right? If you're talking about leveling does remove a lot of the information that you get from the data. So you lose the original values in a sense. You lose the information, but also at the same time, depending on what you want to do, leveling actually allows you to find signals if you make everything to the equivalent baseline. So if you level everything to the median of the sample method, for example, or Z-score leveling, whatever, that will allow you to find the signals in that has already been leveled to a common ground. And that's good. But if you still want to use the original values, then leveling might not work too well for that. There's correction that you can apply to the data, but you lose the signal as well. And where the challenge is, you want to maximize or you want to optimize the signal to noise ratio. Ultimately, at the end of the day, what you want to do is you just want to highlight the fact that your data comes from different places, and you can subdomain your interpretation as such that you identify different processes within each method. And at the end of the day, you can come back to it and see the similarity between the processes and the clusters that you see within each subdomain. And if we're talking about the subdomain that relates to a different analytical method, if we pick my earlier example of elements that are hosted in certain silicates like titanium and zirconium, if we pick those elements, right, different background level, and because of the different detection they method, the different digest, if you have two different methods in the same data set, if you run things like PCA, they would show up as different clusters. But once you subdomain them and you do things like UMAP or k-means or a geochem classification workflow in each one, you can come back to it at the end of the day and combine them all together, which is what I would do. But also, if you think about data that's if most of your data is at the detection limit, right? If you're thinking about one of the methods, 90% of data sitting at the detection limit, then the cluster is basically moot at that point. It's not really usable in a sense, right? You can make assessment. These are all below detection limits, so they would have a value lower than a certain ppm, and therefore, based on that threshold, I think they're this rock type. So you can make that sort of assessment, but you want to flag it in your data as such that this is inference based on the fact that I know this data is below detection limit, if that makes sense.
I think that's beautiful. It's really well said. That said, to close out then, I think this entire podcast has all been about advice, but any further advice that you want to just throw out there to geos working with historic data sets or modern portable technologies?
Having good metadata is important, and I think this is just a call out to not just geological surveys, but people who publish their data in papers and publications to include those metadata in. So just tell people where the data came from, what analytical method. I know if you publish a paper, it's already been included in the paper, but include them in the data if you're attaching it to your paper, for example. Also with public domain data, just include that metadata would be quite good. But also just as a call out, as an industry as a whole, if we live in a world where mining companies can publish some of these data into the world for people to have a play around with, to increase their knowledge and education of what you can do with good real world industry industry-based method. So real world data with the sort of samples that you would send to a commercial lab. So good real commercial lab data. I think that'll be quite useful for the industry as a whole. And you're not really giving your secret sauce or your trade secrets away. An assay is an assay, but it just gives people a better chance to improve. In my naive sort of point of view, I think it can improve your exploration success in a way if more people know what to do with their data. So having good real world data, and I know that Scott Haley publishes a lot of this data in his tutorials. He's actually got some real world data. Some of it has been obfuscated, the coordinates, but I think as a whole, as an industry, I think we can do a bit better with having this sort of data available to the general public to look at.
Yeah, I absolutely agree with this. To me, IP is sits in your people and what you guys do together inside your closed doors. But as you say, data is data. The oil and gas industry regularly shares data. Why can't we in mining? So, yeah, love it. I want to thank everybody for listening to Geochemistry, and a big thanks to Putra Sadikin for stopping by the show, dishing some great tea and providing such great insights into historic data sets. Thanks to our sponsor, LKI Consulting, and to It's Water and Coma Media for our music. And if you want to learn more about the show or submit a request to be on the show, recommend somebody for me to chase up, just go to our website at geochemistry.com. And I'm looking forward to chatting with everybody next month.